Welcome to another Mathnificent conversation. Today we're going to focus on factoring that is necessary for calculus. So we're going to go over a few factoring techniques that if you're in AP Calculus or a regular calculus course will be necessary for your success in the class. We are given this expression and we're asked to factor it. So like previous, we identify our terms. This is a term. And this is a term, and then we decide what technique we're going to use. Well, I have two terms, and I have a binomial that has exponents. So that's going to alert me that I should be looking for a GCF to start. I'm going to do some rewriting so that the term or factor that has a GCF between the two is highlighted. When you're dealing with rational exponents, it's not as easy to see what you can factor out. So just keep in mind, factor out the smallest exponent. So currently 2x minus 1 we have in both of our terms. The smallest exponent is negative 3 over 5, which means that our GCF is 2x minus 1 to the negative 3 over 5. Now, what gets a little tricky is when it's time to divide that out. So I'm going to divide out 2x minus 1 to the negative 3 over 5. In my first term, I've divided the entire thing out, and we know when we divide the entire thing out, that leaves us with 1. 5x times 1 is just 5x. Now, my second term is a little bit tricky. So I remind myself that I'm dividing, and I do a little bit of scratch work. What I'm actually doing is 2x minus 1 to the 2/5 divided by 2x minus 1 to the negative 3/5. Because again, factoring something out just means dividing it out. We know when we are dividing with our exponents, we subtract them. So this is really 2x minus 1 to the 2/5 minus negative 3/5. Double negative supercharges to a positive, and 2/5 plus 3/5 is 5/5. And 5/5 is equivalent to 1. So I go back up, and so that means I'm left with 2 times 2x minus 1 because my exponent is 1. Now we go back and we simplify what's left after factoring. So we have 5x minus 4x plus 2. 5x minus 4x is 1x. So I'm just going to write x and then plus 2. Remember, we never leave anything with a negative exponent. If you need help with that, go to the exponent rules video. 2x minus 1 to the negative 3/5 will move to the denominator and become a positive 3/5 as my exponent. Okay, now we want to factor this expression. Again, we let ourselves know what our two terms are. That's a term and that's a term. Now we look for a greatest common factor. So I do see in each term we have something with a base of x plus 5. So we know that that's going to be a common factor. But I also know that 2 and 6 have a common factor of 2. So 2x times x plus 5 to the 1/3 minus 6 times x plus 5 to the negative 2/3. Okay, so that tells me our GCF, 2 and 6 have a common factor of 2. Our smallest exponent with our base x plus 5 is negative 2/3. So I'm going to factor out 2x plus 5 to the negative 2/3. Okay, now what's left from our first term, 2 divided by 2 is 1. We don't have anything to divide the x, so it stays x. Then we have x plus 5 to the 1/3 divided by x plus 5 to the negative 2/3. So let's do our scratch work. Remember, because we're dividing, we subtract. So this is x plus 5 to the 1/3 minus negative 2/3, which supercharges to a positive. So that's x plus 5 to the 3/3, but 3/3 is just 1. So we're just left with x plus 5 minus 6 divided by 2 is 3. And I divided the entire x plus 5 to the negative 2/3 out. So that concludes that. So this is 2 times x plus 5 to the negative 2/3. On the inside, I'm left with x squared plus 5x minus 3. We don't leave negative exponents, and here's something to be very careful about. This 2 does not have a negative exponent attached to it. It is not inside the parentheses with the negative 2/3, so it will stay at the top with the x squared plus 5x minus 3 and x plus 5 to now the positive 2/3 is on the bottom. Okay, now we have a different expression. So now we're going to look for our greatest common factor. So first we have this term and we have this term. Okay, the greatest common factor between 8 and 4 is 4. The greatest common factor between x and x squared is x. And the greatest common factor between x minus 4 to the negative half and x minus 4 to the half, remember always the smallest, x minus 4 to the negative half. So let's divide out our greatest common factor. 8 divided by 4 is 2. X divided by x is 1. X minus 4 to the negative half divided by x minus 4 to the negative half is also 1. 4 divided by 4 is 1. X squared divided by x is x. And then x minus 4 to the positive 1/2 divided by x minus 4 to the negative half. You may have seen the pattern by now, but let's still show our scratch work. We're dividing those bases, so we subtract. So this is x minus 4 to the half minus negative half. Supercharges to a positive. So that's x minus 4, 1/2 plus 1/2 is 1. Okay, so we're left with here x minus 4. Okay, 4x There's x minus 4 to the negative half. Simplify 2 times 1 is 2 plus x squared minus 4x. We're going to move our negative exponent. Remember, 4x does not have a negative exponent, so it should stay at the top. I'm going to rearrange the terms in here so that they're in standard form. And now x minus 4 is now positive half because it's moved to the bottom. I have a trinomial here. I'm going to quickly check to see if it can be factored. No factors of 2 will add to negative 4. So that concludes our answer. Okay, now our expression doesn't have any binomial factors, but we do still have some rational exponents. So let's identify our greatest common factor. So both terms have x and y. Remember, the quick way to identify your GCF is it's always the smallest exponent. So in the first term, I have x to the positive 1/2, and the second term, I have x to the negative 1/2. So x to the negative half is the common factor. In my first term, I have y to the first. In my second term, I have y squared. The smallest is y to the first, so that's my common factor. So the greatest common factor is x to the negative half times y. Okay, let's divide out our GCF. X to the half divided by x to the negative half, we just saw, becomes x to the 1/2 minus negative 1/2, supercharges to a positive, x to the first. Y divided by y is 1. X to the negative half divided by x to the negative half is 1. And y squared divided by y is y. So x to the negative half y times x plus y. We move our negative exponent. Remember, this guy does not have a negative exponent, so he stays at the top. And we move x, and now we're 1/2 in the bottom. Okay, let's take a look at our last example. Identify our terms, this term, and we have this term. Okay, for my numbers, I have -8 and -64. I know the greatest common factor between the two of those is -8. Remember, if you didn't watch the last video, if the leading term is negative, go ahead and factor out that negative. But if both terms are negative, you definitely want to factor out the negative. Okay, both of my terms have an x factor, and the smallest is negative to the -3/4. Only my first term has a y, so it's not part of my GCF, and only my second term has a z, so it's not a part of my GCF. So my GCF is -8 x to the -3/4. -8 divided by -8 is 1. X to the -3/4 divided by x to the -3/4 is 1. Y does not have a factor to divide by, so it stays y. -64 divided by -8 is +8. X to the 1/4, I'm going to do our scratch work, divided by x to the -3/4. And the more you do these, the more you'll see the pattern. Minus -3/4 supercharged to a positive, x to the 4/4, which is just x. And z doesn't have a factor to divide by, so it stays z. So I'm going to simplify my answer. When you're doing these in calculus, you're more than likely looking for critical numbers. Simplifying is going to be your best friend. If you cannot simplify these down, you are going to have issues identifying your critical numbers. Okay, remember, this guy does not have a negative exponent, so he stays at the top. And we move x now positive 3/4 to the bottom.